Good morning, students. Today we will discuss about the introduction to the 8051 microcontroller. As of now, you people are quite aware about the 8085 microprocessor. So now we will discuss about the basic differences between 8085 microprocessor and 8051 microcontroller. Uh, you people know that the microprocessor unit is a very versatile unit that can process multiple operations. So before going to the 8051 microcontroller, we will discuss about the 8051 architecture. So before the architecture starts, we will briefly uh, view the gist of the microprocessor. That microprocessor has a central processing unit, and the other units like RAM, ROM, uh, IO devices, that means input output devices, some serial communication ports, those are connected externally, whereas the microprocessor has the digital computer, which contains the arithmetic and logical unit that denoted by ALU, program counter, the stack pointer, and some working registers, clock timing circuits, and interrupt circuits. So any numbers of RAM and ROM can be connected depending on the hardware support of the microprocessor unit. Some other devices, some other input-output devices like optical drives, floppy disk drive, hard disk drive, and printers, uh, displays, keyboard, mouse, that all are the peripheral devices and that can be connected with the microprocessor. And the main advantage of microprocessor is it can perform various jobs at a time. Various jobs means what? Various jobs means like when we are doing some assignment work in Microsoft Word in our desktop or laptop. Simultaneously, we can play some music, and simultaneously we can upload some documents or video files to the Google Drive, or we can download some applications from cloud or some website. So these operations can be done by the microprocessor. But in this is the pictorial representation of 8085 microprocessor, not 8085. This is the general in organization of a computer which uses a microprocessor. Some recent advanced microprocessors also. So here you can see these devices are connected with the CPU externally via the address bus and data bus and control bus. So we will discuss about these connections and the significance or significance of address bus and data bus and control bus. So as of now, you know that this address bus locates the address and data bus. Through this data bus, the data between the CPU and these devices are shared. So in the microcontroller, unlike the microprocessor, the RAM, ROM, IO devices, timing control circuit, and IO ports, those are all embedded in on chip, in a single chip. So the CPU contains the arithmetic logical unit, program counter, stack pointer, some registers, and in addition, this is the advantage of the microcontroller, some RAM, ROM, and IO ports, those are included in the microcontroller chip. Some microcontrollers uh, are having ADC and DAC. So what is the use of ADC and DAC in the microcontroller? You know that every real world data, those are analog data. So analog data cannot be processed via a microcontroller. So microcontroller needs some digital data to process. So from real world data, that analog data needs to be converted into its equivalent digital form. So that is done by ADC. And similarly, the reverse phenomena is done in at the output stage. So the processed output is in the digital state, and to use it in the real world applications, that needs to be converted into its equivalent analog form. So some microcontrollers are having ADC and DAC on chip, but basic microcontrollers don't have ADC and DAC on chip, but still they can be connected externally with the microcontroller. So everything is in single chip. So this is the pictorial representation between the microprocessor and microcontroller. You can see the clear difference in the picture. This RAM, ROM, IO port, timer and serial communication ports are connected externally with the CPU. And in microcontroller, these CPU, RAM, ROM, input output ports, timer and serial communication ports that are embedded on chip. Here is the brief of the difference between microprocessor and microcontroller. As we were discussing, that microprocessor doesn't contain any RAM, ROM, IO ports on the chip itself, but the microcontroller has a CPU in addition to a fixed amount of RAM, ROM, IO ports and timer. That is obviously in a single chip. Still, they can be extended depending on the application requirement. This connection of RAM, ROM and external IO devices with the microprocessor makes the whole system bulkier and expensive. But as this microcontroller unit contains RAM, ROM, timer, IO ports and external memory on chip, so this system is very light, and it is available in market like in a very cheap. It is very cheap. Like it will take some 50 or 70 rupees per piece. And as this microprocessor has this external devices connection, so it needs some big space, so it cannot be accommodated in a small circuitry. But a microcontroller can be accommodated in a small circuitry system. Uh, Obviously, this microprocessor, as we have discussed, that microprocessor is a various job purpose device. So it is very versatile, and this RAM, ROM, and IO ports can be uh, connected with the microprocessor as and when needed. But it is not possible in case of microcontroller, as the RAM, ROM, and IO ports, these are single chip and fixed amount. So it is not possible for a microcontroller system. So these are some applications of microcontroller system, like thermostat. It will sense the temperature, and it will display the temperature in the display LCD. So this processing is done by the microcontroller system. Now we can see the coin vending machine. That vending machine receives the coin, and it reads the coin value, and accordingly it dispenses some vending machine, some cold drinks or drinks. So it is based on the 8-bit Motorola 68HC11. And next we are coming to the automatic toothbrush. That is the main microcontroller used is 8-bit Zilog Z8. That means 8-bit means this microcontroller is 8-bit. So as you know from the microprocessor concept, that 8-bit means the data bus is 8-bit bit. And this is the dishwasher system, that is automated dishwasher system, and that can be controlled externally, especially remotely via software interface and cloud. That is an application of IoT also. So it uses this 8-bit Motorola uh, microcontroller. The model number is 68HC05. And finally, this is a very known car to you, that this is the Mars rover that uses a microprocessor that is made by Intel Corporation. That is also a 8-bit microprocessor system. And here this coin changer machine, this, this also uses some 8-bit microcontroller. Some other applications of microcontroller system and microprocessor system also. You can see this RISC. This term is very new. There is reduced instruction set computing. So here we can see, we will come to know that the instruction set of 8085 was very large. Like to move the instruction, there is a dedicated instruction. To copy the instruction, there is a dedicated instruction. To immediate move, There's a different instruction. So, but in case of microcontroller, we'll come to know that by using a single operation, I mean single instruction, we can operate many operations. So now these are some microcontroller survey that can be used by different companies. You can see this Hitachi company that is made by this Hitachi company, this model, and this model has 24 pins in the chip, where this IO, I mean input output pins are 10. The number of the IO pins are 10, and 32 bytes of RAM is there, and 512 bytes ROM is on chip. So this is the 10-bit ROM. This is the special feature of this model. These likewise National Instruments, Texas Instruments, OKI, Toshiba have formulated and designed their own microcontroller. But look, this all the microcontrollers in this table are 4-bit microcontrollers. So coming to the next part, this is the little bit higher level microcontroller. There is a 8-bit microcontroller, that is Texas Instruments, Intel, Microchip, National Instruments, Motorola, Philips, Rockwell, Zilog. Those are some examples of 8-bit microcontroller. We will especially focus on this Intel 8051, which is having 40 pins at a total, and 32 pins for input output pins, and two counters. That is timing counting operation is made by two modes. I mean not two modes actually, that there are two timers and two counters, and this timer and counter operations are complementary. We'll come to that, we'll discuss it later on. And the specialty of this 8-bit microcontroller is 128 bytes of RAM and 4 kilobytes of ROM. So this the specialty of this is 128 kilobyte of RAM and the serial ports. So there are some other examples also. You can see these are the different kinds of 8-bit microcontrollers. Coming back to the higher version of this is a 16-bit microcontroller. For that means it has 16-bit data bus. The width of the data bus is 16 bit, and this Hitachi, Intel, and National Instruments are there. There's some examples. There are number of examples are available. So here you can see this Intel microcontroller 80C196. It has 68 pins in the IC, and 40 pins are used for input output operation. So coming back to the and we are entering to the microcontroller architecture. So there are three architectures. You can see there is von Neumann, Harvard, and modified Harvard. So it is quite simpler when we see this kind of pictorial representation. You can see this the program memory and the data memory is associated with the CPU. Like here, the von Neumann contains a single memory for storing control program and data program. Contains single bus for transferring data to or from CPU. That most computers uses this kind of architecture. So this is the pictorial representation where this memory for program, that is program memory and data memory, those are common. So if a CPU needs to read the memory, I mean program memory, then the data bus and the address bus are same, I mean common. So at a time, data memory and program memory cannot be accessed by the CPU. Whereas in the Harvard architecture, the program memory and data memory is different. So at a time, different, I mean, as the memory segment is different, so if the CPU requires the data memory and program memory at a time, so that can be done by this Harvard architecture. So coming back to the this gist of this, so modified Harvard is also there. So single data and address bus externally, but two separate buses internally. Program data information is separated by multiplexing method. So it is the advanced version of this Harvard architecture. So the features of 8051 are listed as this. You can see this 8-bit CPU that is with register A and B. That is A register nothing but it acts as a accumulator also, and 16-bit program counter and the data pointer, and 8-bit program status word, that is PSW, that is like the status stack register of 8085. Stack pointer is 8-bit. Internal ROM and internal RAM is there, as it was discussed earlier, that this microcontroller includes 120 bytes of RAM and 4 kilobytes of ROM. So and there are 32 IO ports, I mean IO pins. So each port contains 8 pins. So there are 4 ports, namely P0, P1, P2 and P3. Two timers are there, and full duplex serial data communication and receiver, like in the full duplex means at a time this transmission and reception that can be done. And the control registers, that is timer control registers, TCON. TMOD is timer mode registers to select the modes of the timer. Serial control register, that is SCON. Power control registers, that is PCON. Interrupt enable IE, interrupt priority setting registers are IP. And it has two external and three internal interrupt sources, and oscillator and clock circuit. So there is a clean block diagram of 8051. You can see here, this is the block diagram of micro 8051 microcontroller. So here you can see this is the CPU, and this CPU is connected with each of the part, I mean each of the RAM, ROM, timer counter, UART, IO ports and bus control unit uh, with this 8-bit data bus. That it means the data bus is 8-bit wide. There is an interrupt controller that is connected to CPU directly, and oscillator circuit. This is the heart of the microcontroller unit. So this the crystal frequency, the oscillator frequency is 11.0592. This is very important, megahertz. So this operational time, that will be inverse of this frequency. So it will come like some microseconds. So this controller is called microcontroller. Okay. So this interrupt controller, as we have seen in the previous slide, that 2 plus 3, that is 2 external interrupts and 3 internal interrupt sources are there. So these are 2 external interrupts and these 3 internal interrupts. So this is the 4 kilobytes of ROM. Still, as this microcontroller is having 16 bits of address, so it can read or it can execute up to 64 kilobytes of size. Still, the 4 kilobytes of ROM is available on chip. Rest of the space can be connected externally, and 120 bytes is RAM is present. As we have discussed, that timer and counter operation are complementary operations, and here in the 8051 microcontroller, two timers are there, that is timer 1 and timer 0. So this can be also said that two counters are there, counter 0 and counter 1. And in the lower portion we can see this bus control and IO ports, as we have discussed in the previous slide, that there are 4 IO ports, that is namely P0, P1, P2 and P3. And you can see that the name order is somehow different, like uh, we need to write P0, P1, P2 and P3, whereas we have written P0, P2, P1, P3. So there is a significance of this. We'll come to that very soon. And as this is the serial communication, there is full duplex mode, that is transmission and reception can be done simultaneously at a time. And this is the universal asynchronous receiver and transmitter, that is UART. So this is the total block diagram of 8051 microcontroller. Now we can see the CPU and RAM, that is the data bus is bidirectional. For timer counter and CPU, this is bidirectional. CPU and UART, this is bidirectional. Similarly, IO ports and by bus controllers, those are all are bidirectional, except this ROM. As we know that ROM is read-only memory. So CPU can only read from ROM. We cannot write something inside the ROM, right? We can write inside RAM because it is random access memory. But inside the ROM, we cannot write anything. Only the CPU can read from. So this unidirectional port is there. This is very important in this block diagram of 8051 microcontroller. So please keep in mind. So perhaps this block diagram is clear. Now we are coming to the features of 8051 is a quick view. Uh, it was earlier already there. This is the interrupt source. Earlier we have seen that two external and three internal interrupt sources are there. Here we can see this is the one number of extra interrupt are there. So what is this? We'll come to that. Now this is the detailed part of the 8051 microcontroller. You can see this arithmetic and logical unit, that is the ALU, that is connected with the A and B registers. So it is a somehow complex diagram, but still you can use the previous diagram as it was there. This diagram you can use it. Now coming back to the 8051 family members microcontroller. So we are comparing between 8051, 8052 and 8031 microcontroller. This on-chip ROM in 8051 is 4 kilobytes and 8052 8 kilobytes. But surprisingly, in 8031 there are no on-chip ROM, whereas 128 RAM only is there. And 8051 and 8031 are both are having two timers, 32 IO pins, one serial port, and 6 interrupt sources. So this some examples of 8051 microcontrollers from Atmel. So we are very much focusing on this 8589C51, which are having 4 kilobytes of ROM, 128 bytes of RAM, 32 IO pins. This is a total 40 pin IC. This is the packaging is 40. Two timers are there. 6 interrupt sources, two external, 3 internal, and one is power interrupt, reset interrupt, and it can be operated by the 5-volt supply. So there are some other examples.